Okay, so we're going to have a look at moles calculations, particularly with volumes of gases. First thing to consider is units. I've drawn here a cube, and that cube is 10 centimeters by 10 centimeters by 10 centimeters, which means 10 by 10 by 10 is 1,000 centimeters cubed, and we know that's a litre. If you consider here, we've got 1 decimeter. 1 centimeter is 1/100th of a meter. 1 decimeter is 1/10th of a meter. 1/10th of a meter is the same as 10 centimeters. So this distance here, if it's 10 centimeters, it's also 1 decimeter. So 1 litre, remember this cube is 1 litre, is equivalent to 1 decimeter times 1 decimeter times 1 decimeter cubed. Sorry, 1 decimeter, which is 1 decimeter cubed. So just a bit of background really. 1 litre, this is a litre, is equivalent to 1,000 centimeters cubed, which is also equivalent to 1 decimeter cubed. And the reason we use 1 decimeter cubed is because the L for litres can be mistaken for a 1. Okay, that's the most important thing on that slide. So we want to consider molar gas volume. 1 mole of any gas, it doesn't matter what the gas is, occupies 24 decimeters cubed. So if we had 48 decimeters cubed of the gas, we'd have 2 moles of gas. And that gives us a new moles equation. Number of moles equals volume over 24 decimeters cubed, where this volume here is the volume of a gas, okay, not liquid volume. This equation here is all related to gases. So have a go with this question here. And the idea is you've got to fill in the formula of carbon dioxide here. If you had this volume, how many moles would you have? Give the name, here's the formula. If you had this volume, how many moles would you have? Press pause until you're ready to go. Here's an equation to help. And there are the answers. Make sure you get those correct. Now we'll extend that and see if you can link it to some of your prior knowledge, which looks at this equation here, number of moles equals mass over molar mass. If we've got this number of moles, bearing in mind this formula, what's the mass? Okay, so again, press pause on the video, see if you can work those out, and you can check your answers in a moment. There are the answers. Hopefully I've got them correct, hopefully you've got them correct too. Next, here's an example of a question. 3 grams of carbon is burnt in excess air. What volume of gas is produced? So what we'll do is we'll work through this. And you need to start with the word equation and turn it into a balanced symbol equation. Again, press pause on your video and see how you go. You can double check that in a minute. There's your word equation. And there's the balanced symbol equation, ever so easy. Next step is to look at we know the mass of carbon, so we know most about the carbon. Let's work out the number of moles of carbon. Once we've got the number of moles of carbon, then you should start to relate moles of carbon to moles of carbon dioxide, because that's what we need to work out the moles of gas produced. And you should be able to see here it's a 1-to-1 ratio here. So if we start off with 0.25 moles of carbon, we also produce 0.25 moles of carbon dioxide. Using our equation, number of moles equals volume over 24 decimeters cubed, we can find out that that number of moles of carbon dioxide is 6 decimeters cubed. So when we produce 6 decimeters cubed of carbon dioxide when we burn 3 grams of carbon. Next question, see how you go with that one. Again, press pause on the video until you finish the question. Okay, first the word equation and then balanced symbol equation. Sodium plus water produces sodium hydroxide plus hydrogen. The balanced symbol equation reads that. Oh, it doesn't. I've forgotten 2 here. Everything else is correct there. Number of moles of hydrogen is volume over molar volume, which is, now I've changed this to 120 over 24,000 because this is written in centimeters cubed. Okay, you can change that to decimeters cubed, in which case it would be 0.12 decimeters cubed divided by 24. Still gives the same answer. So just be aware of that. Ratio of sodium to hydrogen. Remember, I've got 2 there. I've forgotten that. Sodium to hydrogen is 2 to 1. So if we've got 0.005 moles of hydrogen, we need double that of sodium, which is 0.01 moles of sodium. And then last of all, we've got number of moles of sodium equals mass over molar mass. And 0.101 equals mass over 23. So the mass of sodium is 23 grams. Okay. Have got some examples and see how you get on.